Let's talk about solving nonlinear systems algebraically. So instead of looking at their graphs on Desmos or graphing them by hand, we're actually going to solve them algebraically, which essentially is talking about using substitution. And we used substitution back when we were doing linear equations or linear systems, so it's really the same steps. What I need you to do is on a piece of paper, you should be taking notes along with me. I want you to determine the solution or solutions because remember there could be two, there might be one, there might even be zero, and we're going to do it algebraically. So the first step is you need to actually substitute. Okay, so we're going to use substitution. And what we can see here is both of these are y equals. Y equals 3x squared plus 2x minus 8, that's our parabola, and y equals negative 4x plus 1, that's our line. But they're both set equal to y. So if y equals negative 4x plus 1, I can substitute negative 4x plus 1 in for the y here. So I get negative 4x plus 1 equals 3x squared plus 2x minus 8. Now, I know it looks like a long equation, but really this is just a quadratic, and we've been solving quadratics for a long time. So step 2 is just solve the quadratic. And because we learned so many steps, this is where you get to kind of choose the path that you want to take. We've learned that you can solve by factoring, which you need to set it equal to 0. You can solve by quadratic formula, which is also meaning set it equal to 0. We have some other options. Sometimes we can solve by square roots, but that's only if there's no b term. So we can't use that here. And then we can also sometimes solve by complete the square, but we prefer to have a leading coefficient of 1, so we're not going to use that. So really, if it were me, I would be choosing between factoring and the quadratic formula. So pick one of those. So if I'm using either of those, I need to get it set equal to 0. So I'm going to add 4x to both sides first, and I'm going to subtract 1 from both sides as well. So that means I get 0 equals 3x squared plus 6x minus 9. Choosing the path that you want, it's totally up to you. I'm going to use the quadratic formula just to kind of review that. So negative b plus or minus the square root, b squared, so 6 squared is 36, minus 4 times a times c, all of that over 2 times a, so 2 times 3. So take a second, pause the video, see if you can simplify this, and then check back with me. So I get negative 6 plus or minus the square root of 144 over 6. The fact that this is a positive discriminant tells me that there are going to be two solutions here. So we have negative 6 plus or minus 12 over 6. Negative 6 plus 12 is 6, over 6 is 1, and negative 6 minus 12 is negative 18, over 6 is negative 3. Now this does not mean that my solution is the point 1, negative 3. Remember, we were solving for x here. So we are actually expecting two solutions. This is a situation where the line and the parabola cross in two spots, right? So really what we just found is that our solutions are the coordinates 1 something and negative 3 something, right? Because x equaled 1 and x equaled negative 3 are x's of our solutions. So the last step is you need to find your y's. So solve for y now. For both, or if there's only one solution, you do it for that one. So for this, remember I can plug in 1 into either equation. So y equals negative 4 times 1 plus 1. Well, negative 4 times 1 is negative 4, plus 1 is negative 3. And here, if I plug negative 3 in, y equals negative 4 times negative 3 plus 1. Negative 4 times negative 3 is 12, plus 1 is 13. So our 2 points are 1, negative 3, and negative 3, 13. Those are our two solutions. We could check this graphically on Desmos. I can see that both of those points are confirmed. Let's try another example. So example 2, again, we have a quadratic and a linear equation. So your first step is to substitute. I can see y is negative 8x minus 24, so I can substitute that in for y here. So negative 8x minus 24 equals negative 5x squared minus 3x plus 6. Now we solve this quadratic. I'm going to go ahead and add 8x to both sides and add 24 to both sides so that it's set equal to 0. So we get negative 5x squared plus 5x plus 30 equals 0. I'm going to go ahead and change it up a little bit to solve this one. You could use quadratic formula. I'm going to go ahead and do it by factoring. So I'm going to factor out, this obviously has a GCF of 5 or negative 5. You can choose positive or negative. I'm going to factor out the negative 5. So I'd have x squared minus x and then minus 6. We want to factor this. Maybe pause this video, try to factor it on your own completely. And you should get negative 5 times, if you split the middle, you're going to get x minus 3 is one of the factors, and x plus 2 is the other. So if this is set equal to 0, then that means I should take each of these individual factors and set them equal to 0 and solve. So x minus 3 equals 0, and x plus 2 equals 0. Solving this, we get x equals positive 3, and over here we get x equals negative 2. So again, this means that we have a situation where you have a parabola crossing the line in two spots. So our points, our solutions, are 3 something and negative 2 something. So when we plug these in, that's our final step. If I plug 3 back into this equation, negative 8 times 3 is negative 24, minus 24 more is negative 48. And if I plug in negative 2, negative 8 times negative 2 is 16, minus 24 is negative 8. So our two solutions are 3, negative 48, and negative 2, negative 8. I'm going to put up one more problem. I'm going to ask that you go ahead and try it on your own in your notebook. Let's see how you do. If you want to check it with Desmos, you can, but pause it and then come back and check your answer with me. So here is what I did. I used substitution. I got it set equal to 0, and when I did that, it was 0 equals 2x squared plus 3x plus 4. I noticed it wasn't factorable because 2 times 4 is 8, and if I go through and list the factors of a positive 8, that's 1 and 8, and 2 and 4, none of those would add up to 3, so it was not factorable, so I chose the quadratic formula. But when I use the quadratic formula, I got negative 23 as my discriminant. A negative discriminant means that there is no solution. A positive discriminant would get me 2 solutions, and a discriminant of 0 would mean 1 solution. So if you need more practice, go back through. I'll post some other practices, but go ahead, practice this, and let me know if you have any questions.